in your whole process, you've got your double bond. That reacts with ICl first, and what does ICl do? Adds across the double bond. So we end up with something like this. Okay, but what we do is we add the ICl in excess. So let's say, for example, let's give it a starting value. How much ICl do we want to add? Just give me a number.
20 grams.
20, okay, we'll go for 20. We'll go for 20 moles, which is probably a lot more than what we would. Okay, so 20 moles we add in initially, right? But we're not going to use all that 20 moles, that's what I mean by using it in excess. So we're going to be left with some ICl. So what we do, a bit like our back titrations last year, is we react ICl with what? Can you remember? What's the next stage? Potassium iodide. Okay, what do we get from that reaction? Okay, we get iodine, I2, and potassium chloride. Iodine is something I can titrate. So I then take this. Do you remember what I titrated against? Good, sodium thiosulfate. So we just normally represent it by the thiosulfate ion. What does that give us? It regenerates something. Iodine. Said iodine. Slightly different. Okay, and I need to put a 2 in front of that to balance it. Okay, so I need to go this far because this is the only titration thing that I can do. From that, I get, because my sodium thiosulfate is standard, I know the concentration of it. Once I then have a volume, I can work out the number of moles by doing N equals CV. Okay, so say for example, and this is just what we did earlier, you work out that you have 2x moles of sodium thiosulfate, yeah? Yes? How many moles of iodine did that react with? X, because of the 1 to 2 ratio, it reacted with X moles of iodine. Remember, I got this from here. So that means how many moles of iodine did I liberate with my potassium iodide?
1 actually.
Yeah, perfect. Perfect. Okay, the thing I'm interested in, because the thing I added across the double bond first of all, was this ICl. Okay, I can work out the number of moles of ICl. My ratio is just 1 to 1. So how many moles of ICl did I use? X. Okay, so remember, this is my leftover ICl. It's the stuff that didn't react with my double bonds. Are we okay with that? Because we're working back the way? No? Yeah. Okay, so how do I then work out how many ICl I did use? Take it away from what? 20. See you later.
Bye later.
Okay, so moles reacted. Equal initial minus the leftover, which in our example we took as 20 minus X. Is that okay? That teaches us kind of how we do these titrations. It's just what you find out. So when you do your titration, you'll get a value of what's in your F. Yeah, kind of. We'll not do it as a practical. You would have to do the calculations when we get to module 5. This is just explaining what's happening. So we do this titration, right, and we get a value for our thiosulfate. That's our titer, is of sodium thiosulfate. This thing down at the bottom. What colour will I make it? Green. Yes? Okay, and that works out the leftover moles of ICl, whatever. Anyway, we repeat this whole thing again, but we do it without ever adding it to the oil in the first place. So we do it without having done this step. Okay. So none of my ICL is going to be used up in that situation. So what does that mean about X? Will it be bigger or smaller? Remember in this one. So this is kind of the leftover. If none of it has reacted, is it going to be bigger or smaller?
Bigger.
Bigger. Yeah? So I'm doing, this is what we call a blank titration. Okay, so this value is going to be bigger. Again, I react it with my potassium iodide, liberate my iodine. I then titrate that with my sodium thiosulfate again. So what I'm going to find with my sodium thiosulfate titer, what's it going to be when I do it blank? Is it going to be smaller or bigger?
The titer?
Yeah.
It's actually bigger, and then what you get when you take it away is going to be smaller. I don't know what you mean. A titer.
Titer is the volume you add from the burette. So you've got more ICL, so you're going to produce more I2, so you're going to need more thiosulfate to react with that. Yeah, is that okay? So when you do your blank titration, the point of that is saying that your blank titration is always going to be bigger. To work out your iodine value then, page 26, you've got there your titer, and when you react your ICL with the oil, we take as V1, the titer with no oil, the blank one we take as V2. And then we put this into our equation here. Again, my fuller explanation completely explains where this comes from, and it comes all from the mass of iodine. Can we remember what our definition of iodine value is? So it's the mass of iodine required to saturate 100 grams of your fat. Okay, so that's where iodine value is. Put it into this equation. V2, which is which titer?
No oil.
Good, blank. Minus your V1, which is the one with the oil, times by 1.269 divided by mass of the oil. Going back to this, you'll notice your units are blank. What I want you to do is look at this definition. Definition of your iodine value. What are your units going to be?
Did you not find the units from the equation?
Oh yeah.
No. So it's the mass of iodine,
Just grams.
which is grams. Oh, Shane, you're on fire.
Emo.
Per 100 grams of fat, required to saturate 100 grams of fat. Kind of just.
Grams. How is that on fire? Come on, remember this?
Mass of iodine required to saturate 100 grams of fat. So what's the rest of the units going to be?
Grams to the minus 2 or something.
The gram from year 11. What's your solubility values we're in?
What?
Grams per.
So think of the definition of solubility, the mass of solute required to saturate 100 grams of water at a particular temperature. So it was grams per 100 grams of water. So we are trying to saturate 100 grams of fat. So it's going to be grams per. Not quite. It's not water. We're looking to saturate 100 grams of fat. So it's the mass of iodine required to saturate per 100 grams of fat. The grams of iodine.
Wait, that's not
a unit.
Is
Look
that?
at a number be a unit. It's like 1 2s.
How can it work?
Yeah. No, I can remember the word. Oh, fat, yeah. That's like saying the number 2, 2s. You can have 2.
I'm leaving this running.
Then grams on castle then or something? So it's like 1 over 100.
No, because you're saying
You would have like 1 over 100 grams.
Excuse me.
1 over 100 grams.
it's grams of iodine
That makes it much better.
So is that not just 100 fat?
No, 1 over 100 fat.
Well, how can fat be?
Yes. 100 fat, whatever that is.
How can 100 be a unit?
She's still
grams of iodine.
No, but like you have meters per second.
Can I just bring you back a wee second to the definition? It's the mass of iodine, which you said was the grams of iodine, required to saturate 100 grams of fat. Grams per 100 grams of fat. Okay, this is an example, and yes, it looks crazy, and it is crazy, but there's about 2 bits of information that we actually need from this. So the first thing is, and cover it up with your left hand, cover up your equation of iodine. Okay, cover it up with your right hand then. Your iodine value You need to get this into your head. Write it 100 times at home this evening. Doesn't matter.
What are we even doing?
I don't know what we're figuring out.
Are you clean?
Yeah, miss, what do we find?
That's stage. Sorry.
Okay, can we just do this and then we'll see? Right?
Where does winch come into this? I have no idea. I missed a lot earlier on.
Okay, so what does V2 represent?
Volume of the oil. No,
The blank. The blank volume. Okay, is that alright? So which one is my blank volume? Read the question. The endpoint occurred with 12.5 mils of thiosulfate when a blank titration was carried out. 25.4 mils was required.
Well, that's blank on there, 24.
25.4. Okay, what's my V1 then equal to?
Pardon?
What's V1?
That would be 12.5.
Be the
How
12.5.
do you know what you're doing here?
You just put in the equation, I don't understand. You just like...
Okay, we're timesing that by 1.269. Don't forget your brackets though, because obviously we need to do that before we do our multiplication.
I really don't mind doing so many numbers.
There's only 2 numbers you need, woman.
Okay, and then you need to divide by your mass of your oil, which is where?
It's not always going to be 100 though.
No, it's the mass of oil that you use, which is 0.2 grams is right at the start of the question.
100 grams is 0.24.
That's what our equation gives us. It can. So divide by 0.2, that's the mass of your oil. And that works out as, oh, I worked it out somewhere. 81.9, what are my units?
Grams per fat. Grams per...
Grams per 100 grams of, well, we could say olive oil here.
You can't change the units, miss.
Okay, we'll say fat then.
Is that the answer? Like, is that it done?
Yeah, literally that's it.
Is that
Grams
done?
per 100 grams. No, not quite. Right, so over on the next page, just very, very quickly, it just gives you an idea. And what did we say? The higher the iodine value, what does that mean about the structure of the fatty acid? It's more unsaturated. Okay, so in this, which is your most unsaturated fat there?
I'm tempted to say soya.
Soya, you would be tempted, right? Yeah, so that's the most unsaturated. And in terms of health, is that good or bad?
Pardon?
In terms of health, would that be good or bad?
Bang on.
Okay.
No butter's bad, like, it's like, if it's unsaturated,
Yeah,
it's
it's
good.
large.
Yeah, so saturated fats are the not so good ones. And also what we were saying earlier was
I
plant
thought ours was the worst.
oils / fats, do they tend to be saturated or unsaturated?
Unsaturated,
Un?
but it depends on the
Okay.
moment.
And animals, so sorry, this is plant.
Why did you write you in?
Unsaturated. Okay, I'll say unsat.
No, that's stupid.
What were you going to say?
Okay, and this is animal. I can't spell animal. Animal, they tend to be saturated. Listening, please. Do your iodine values agree with that?
Looks that way.
Why does it look that way?
Just constantly going down.
Decreasing, you go down the route. Hence the trend.
Okay, well, not necessarily that it's decreasing, but what do you notice about my plant values compared to my animal values?
Twice. Well, so
Yeah, they're a lot higher. So that means they're more unsaturated, so they correspond with them. Happy days. So as I said earlier, this comes up all the time, and so you need to know this experimental determination inside out. It's all about weigh the oil, dissolve it in your wedges or ways, whatever. Stand in the dark. Why do we do that? To prevent
Radical formation.
photochemical.
it's the
Oh,
same thing
wrong
like
one.
when you're out in the air, but just radicalise.
To prevent photochemical. This is earlier, but just
Talking about Joe DeLazio or something.
Oh, yeah.
Yeah, so I can get someone who I feel he's like a person.
okay. Great. Is that fine? Right. Let's do this one other example. See if you can do it yourself. See if you can remember your equation.
V2 minus V1 times 1.269 over massive.
Great. So I'm just going to do IV as in iodine value.
Have you ever heard
only heard
You
this.
do, you want, you just...
I've heard to say.
Okay, what's your V2 in this case? Blank titration?
Oh.
It's not down to these.
It is
I'm
one
begging
more
you,
thing.
please.
Yeah.
We had different
So
versions.
there's one, the first one's definitely regular.
Blank titration is 19.5.
It's actually Carlos, and I thought the bombs did the original.
Your the normal titer with the oil in it.
But on
Iodine value.
I realise I'm not saying. I'll try and read this question.
What's your other volume?
So really,
Tighter thing.
really what you do is just select 20 centimetre cube.
Oh yeah.
Yeah. Well, as long as you don't look at the 10 centimeters cubed, the 250 or the 100. As long as you don't look at
How do you
that.
know which ones? You said blank and stuff?
Because it says the liberated iodine was found to react completely with 6.2 centimeters cubed of 0.1 sodium thiosulfate.
And that's your V1,
That's your V1. And then it says,
which is with or with.
yep. And then it says your blank titration.
What do you mean with or with? How does that mean?
That is when you add your ICL to the oil and then you take the stuff that's left over, then react it with your Ki, and then take the liberated iodine and react that with the sodium thiosulfate, yeah?
Yeah. Spot on.
But without the oil, you skip the first step, so it's just ICL plus your potassium iodide gives you liberated iodine, which you then titrate against sodium thiosulfate. Simple.
How do you not know about that? I've not forgot all this. Did you not, like...
Oh, I've totally forgotten it. Like, divided by the mass of your oil, which is 0.1 in this case.
Yeah. Is that it?
So the volume
Which is what?
Sodium thiosulfate is the V2, or V1.
Good. 168.8 grams per 100 grams of fat or olive oil. How would you expect the iodine value of an animal fat to differ from that of olive oil?
It would be much lower.
Yeah, okay, lower,
More saturated.
because it's more saturated. How else could we say that? More saturated or less what?
I get that time anyway. Not all the time, but I get that.
Just because that's what we're measuring. We're measuring the degree of unsaturation. We're no, not really. But we're measuring how much of the ICL will add across the double bonds. That's going to be more if there's more double bonds there. So that makes our iodine value higher.